Welcome back to the video lecture series on embedded systems. This is lecture number 3. So in the previous lecture we discussed about thumb 2 technology, and in today's lecture we shall discuss about the architecture of ARM Cortex M3. The thumb 2 technology, in that we have seen that the Cortex M3, it supports both 16-bit as well as 32-bit instructions using or the data types with the use of a single instruction itself. That means there is no need to use separate instructions to handle 16-bit data and 32-bit data separately. So coming to the today's uh, lecture, that is architecture of ARM Cortex M3. Basically the architecture of any material or anything, it describes the brief things which are there in that particular material or particular thing. Say for example, if you consider a constructed house, so if you have the 3D model of that or some model blueprint of that, so there you will see that it will be having like 2 BHK, one hall, one kitchen, etc. and etc. So that is nothing but the architecture of that home. Along with that, they also specify the dimensions, right? So here, in the same way, for a controller or an architect processor, the architecture describes the main units or the functions present in that particular controller or the processor. Now, if you look into the ARM Cortex M3 processor architecture, it has got the mainly 2 points, that is processor core system, that is the core system, and within that it has the ALU, register bank, decoder, instruction fetch unit, memory interface. All these are a single unit. Then we have NVIC, that is non-vectored interrupt controller. There is a separate debug system unit is present, and one special thing what we see here in ARM families is memory protection unit. So this is not seen in any of the microcontroller. We shall see the things in detail in the coming slides. Followed by instruction bus, data bus, then debug interface, bus interconnect. Now, if you look into the few blocks over here, we shall discuss the few blocks in detail. That is register bank, then memory protection unit, and even NVIC. Okay, but if you look into the ALU, that stands for arithmetic logical unit. So ALU will be there in every processor or every controller that is responsible for performing arithmetic and logical operations. Okay, then comes something like decoder. Decoder, it is the one more common thing which will be there in any of the controller and processor. Its job is to decode the instruction given by the users to the controller or processor into a machine understandable language, and vice versa also. Then instruction fetch unit, whatever instructions we provide to the controller or processor, that will be read by this instruction fetch unit. Later it will be decoded by decoder and it will be given to the particular ALU through the registers. Okay, then after all these things we go to the debug system that we discuss in detail in the coming classes anyway. Okay, now let us uh, explore the register bank first. Okay, before that let us go through uh, the very basic highlights of Cortex M3. The Cortex M3 is a 32-bit microprocessor. It has 32-bit data path, that means data bus, 32-bit register bank, and 32-bit memory interface. 32-bit register bank means each register is having 32-bit capacity. So it can hold a data of 32 bits. In ARM, as I told earlier, one word is referred as 32-bit value. Okay, half word is 16-bit and one byte is 8 bits. Okay, double word means 64-bit. The processor has a Harvard architecture, which means that it has separate instruction bus and data bus. So a Harvard architecture advantage is, since it will be having separate instruction bus and data bus for both RAM and ROM. So even one memory, either RAM or ROM, if it gets damaged, so only you can replace that particular memory. No need to replace the entire memory as in case of von Neumann architecture. This we shall see in module 3 as well in detail. Okay. So the overall advantage is it will allow the instructions and data access to take place at the same time. Okay, because of RAM and ROM. So not only that, the performance of the processor also increases because of the data access do not affect the instruction pipeline. So the instruction and data buses, since they share the same memory space, okay, so in other words, you cannot get 8 GB of memory space just because you have separate bus interface. So that is an example. Okay, so as I told, if you have the controller, you cannot change the things. Then for complex applications that require more memory system feature, the Cortex M3 processor has an optional memory protection unit. So that we shall explore in detail later. And also it will support both little endian and big endian memory systems. Again, these things we shall see in the module 3 as well, or at the end of this module I will be adding additional lectures, so there these things will be covered. Okay, the Cortex M3 processor includes a number of fixed internal debugging components. These debugging components are they will be providing operation supports as well as features such as breakpoints and watch points. Okay, so another feature of ARM Cortex M3 is it supports three-stage pipeline design. So three-stage pipeline design means, a pipeline means it is like a parallel processing of the data. Okay, so here pipelining refers to if the controller or processor, if it is, say for example, the pipeline concept is like fetch, decode and execute. While instruction first is getting fetched, decoded and executed at the same time, second instruction, okay, will be fetched, followed by it will be decoded. When first instruction is getting executed, second instruction will be decoded, then it will be executed. When the second instruction is being decoded, third instruction can be fetched. When the second instruction is being executed, it can be decoded and executed. This is nothing but the three-stage pipeline system. Okay, then It also has 32-bit addressing, which supports 4 GB of memory space. So always remember 2 to the power the address bus capacity. So it is 32-bit. So that is approximately equal to 4 GB. Okay. And the bus interface that is used by ARM is AMBA bus, that is Advanced Microcontroller Bus Architecture. Usually we see this kind of AMBA bus in the mobiles nowadays. Okay. And also an interrupt controller called as non-vectored interrupt control, which supports 240 interrupts requests and from 8 to 256 interrupt priority levels. Okay, so different levels are there. So what are these NVIC and all, we shall see in detail shortly. One more feature of ARM Cortex M3 is it supports for various features for operating system implementation such as system tick timer and shadowed stack pointer. Sleep mode support is also there and various low power features. So sleep mode, it means whenever the there is no operation is being carried out, so after a certain amount of time the processor will stop all the activities and it will go to sleep mode. And by invoking some interrupts you can re-switch to the original working style. So it is just like if you put the laptop for laptop ideal for long time, so it will go to sleep mode. So with the press of key or slight uh, press of mouse or variations, it will again turn on the system. Okay, and it also supports an optional memory protection unit to provide memory protection features like programmable memory or access permission control. And also it has support for bit data access. Regarding the memory protection unit, we shall see in the coming slides once again. Okay, that is in the various units of the processor we shall see in the coming slides or maybe in the next lecture we shall see that. Basically the memory protection unit it will use to protect the features like programmable memory or access permission control. Okay, and one more is support for bit data access in two specific memory regions using a feature called bit band. Okay, this is a very important feature. So wherein if we have say one register like R0, okay, so there it will provide you the access to program particular bit of that register. Okay, then these are the few features what we have discussed. In the next lecture we shall discuss about various units in the architecture in detail. So in the examination also, if they ask you to describe the architecture of ARM Cortex M3, along with these few highlighting points, you need to explore the what kind of registers are there, NVIC and all one by one. Okay, thank you.